This is my video 1 for Computer Science 345, Computer Networks, covering chapters 1 through 6. So chapter 1, we talked about networking and introduction to networking. We learned about network models, different topologies, multiple protocols, LANs, MANs, and WANs, and the 7-layer OSI model. So for network models, we talked about the two that we talked about mostly were peer-to-peer network models, which use a mesh topology. Each computer or peer shares resources with other computers or peers directly without a centralized control. And then client-server network model, resources are managed through a centralized directory database. For topologies, there's physical topology and logical topology. Physical topology refers to the network's hardware and how the devices form a physical network. Logical topology refers to how software controls access to network resources and how certain resources such as applications and databases are shared on a network. Some of the topologies that we discussed were star, mesh, bus, hybrid, and ring. Area networks we discussed. So we talked about local area networks, or a LAN, which usually utilizes a star topology because there's a switch that's being used as the central device. A MAN is a metropolitan area network, which is a group of LANs that are in the same geographical location. And then a WAN is a wide area network, which is a group of LANs that spread over a wide geographical area. A PAN is a personal area network, which is a network of personal devices. So like a smartphone, Bluetooth headphones, and a smartwatch that are all connected would be an example of a personal area network. And then the OSI model, which is the Open Systems Interconnection model, we discussed. That was like the main focus of chapter 1. It's 7 layers. So layer 1 is the physical layer, which is responsible for moving individual bits from one device to the next. Layer 2 is the data link layer, which is responsible for moving frames from one hop to the next. Layer 3 is the network layer, which is responsible for delivery of individual packets from source to destination. Layer 4 is the transport layer, which is responsible for process-to-process delivery. The session layer is layer 5, which is responsible for stabilizing, maintaining, synchronizing, and terminating interaction between sender and receiver. The presentation layer is layer 6, which is responsible for taking care of syntax and semantics of the information exchanged between two communication systems. And then layer 7 is the application layer, which is responsible for providing services to the user. Chapter 2 discussed infrastructure and documentation. So we talked about network layouts and diagrams, labeling and naming conventions, business documents, and asset management. So for network layouts, we talked about the physical layouts of the networks. So we talked about entrance facility, or the EF, which is the location where an incoming network service enters a building and connects to the building's backbone cabling. The demarcation point, or demarc, is the point of division between the telecommunication service carrier's network and the building's internal network. The main distribution frame, or MDF, is also known as the equipment room, or is the controlled environment that holds the main cross-connect between the service provider's network and the organization's LAN or WAN. The data room is an enclosed space that holds network equipment. In the data room will be racks that hold various network devices and equipment. And then we talked about a patch panel, which is a panel that's usually mounted on the wall or onto a rack. That's where cables converge in one location, and it acts as a central termination point. And then we talked about the intermediate distribution frame, or IDF, which is the intermediate connection between the main distribution frame and end user equipment on each floor of each building. Then we talked about network diagrams and documentations. Network diagrams are graphical representations of a network's devices and connections. Network documentation is used to provide communication among coworkers to maintain the secure network information. Request for proposal. So these are business documents that we discussed. There's request for proposal, memorandum of understanding, master service agreement, statement of work, service level agreement, and then master license agreement. Yeah. So then asset management, we discussed, we talked about the mean time between failures, which is the average time that a device works before it fails. We talked about the mean time to repair, which is the average time needed to fix a device after it fails. Redundancy is, so if one part service or connection fails, another will take over, which this eliminates the single point of failure. Single point of failure is caused when one part service or connection fails and another part of the network that's relying on that on the part that failed goes down also. That would be an example of a single point of failure. Chapter 3, we talked about addressing. So we learned about MAC addresses, IP addresses, ports and sockets, domain names, and domain name systems. MAC addresses are media access control addresses. They're embedded on every network interface card or NIC. There's two parts. So the first 24 bits are the organizationally unique identifier, and then the last 24 bits make up the extension identifier or the device ID. Internet Protocol or IP it's used to find every computer in the world if the IP address is public on the internet. There's two different versions, so there's IPv4 and IPv6. IPv4 is a 32-bit address, and IPv6 is a 128-bit address. Ports and sockets. So ports, is a number that's assigned to an application that receives data. So port numbers range from 0 to 65,535. The last 16,000 port numbers are dynamic and private ports. Dynamic ports are they're assigned by client or server as need arises, and then private ports are assigned by a network administrator. And then sockets combine a host's IP address and the process's port. Domain name system, DNS, is designed to associate computer names with IP addresses. Namespace is the entire collection of computer names and their associated IP addresses stored in databases on DNS name servers. And then resolvers are DNS client that request information from DNS name servers. Chapter 4 is protocols, so we learned about a lot of different protocols, such as TCP, UDP, IP, IMCP, ARP. We also learned about data states and key encryption. So for some of the protocols that we covered TCP, which is Transmission Control Protocol, sends a checksum, and then the host generates another string that matches the generated checksum. User Datagram Protocol, or UDP, sends data, but no verification of receipt. IP, Internet Protocol, specifies where data should be delivered. IMCP reports on the success or failure of data delivery and is used in troubleshooting. And ARP maps IPv4 addresses to MAC addresses. So there's three different data states. So there's at rest, in use, and in transit. If data is stored, it's at rest. If it's being accessed, it's in use. And if it's being moved, it's in transit. Two different kinds of key encryption that we went over were private key encryption, which is where a single key is used that only the sender and the receiver know. So it's symmetric because it's the same one key is being used. Public key encryption, a private key is known by the user, and then a public key is used to decrypt. That's asymmetric because two different keys are being used. Chapter 5, we talked about cabling. We covered a lot of different things, such as cable types, noise, frequency, fiber connectors. So frequency is the number of times that electrical signal can change its state per second. Bandwidth is the theoretical amount of data that could be transmitted during a given period. Throughput is the actual amount of data that is transmitted during that given period. Noise or interference, there's two common types. So there's electromagnetic interference, which is caused by other sources of electrical activity, and then there's crosstalk, which is caused by signals that are traveling over a wire or cable that it interferes with other signals. Attenuation is the loss of a signal strength as it travels away from its source, and latency is the delay between transmission of a signal and its receipt. Full duplex is when a signal can travel in both directions simultaneously. Half duplex means signals can travel in both directions but only in one direction at a time. And simplex means the signals can only travel in one direction. Cable types, there's the coaxial cable or coax cable. It's the foundation of Ethernet networks. Twisted pair cable is, there's two kinds. There's unshielded and shielded. Unshielded twisted pairs are cheaper but less resistant to noise, and shielded twisted pair is more expensive but also more resistant to noise. Single mode fiber has a narrow core diameter and can travel very far with minimal signal loss without using repeaters, and multi-mode fiber has a large core diameter and it's not suited for distances over 700 meters. Chapter 6, we talked about wireless networking. So we talked about different kinds of antenna. So a directional antenna issues a signal in one direction. An omnidirectional antenna issues and receives wireless signal in all directions. And then the range is the geographical area in which an antenna or wireless system can reach. We talked about radio frequency identification, or RFID, which uses electromagnetic fields to store data. Propagation is the way in which a wave travels from one point to another. And then refraction, reflection, scattering, and diffraction are different ways that a wave will interact with different mediums. We talked about main design types of wireless networking. So there's SOHO, which is small home office, or small office home office. Uses a modem, SOHO router, range extenders, desktop, laptop computers, smartphone tablets, and other Internet of Things devices. And then a corporate or enterprise design will use a wireless site survey to determine what the company needs, how they need to set up their networking equipment, where they need to set it up so that it will work at like maximum efficiency. And then finally, we talked about Wi-Fi network security. The two kinds that we discussed were WEP and WPA. WEP is wired equivalent privacy. It uses open system authentication or shared key authentication. And WPA, it dynamically assigns every transmission its own key. Two of the kinds that it uses, authentication it uses, is remote authentication dial-in user service, or RADIUS, or EAP, which is extensible authentication protocol.